I want to talk a little bit about maintenance before we go to work. First thing I do with my saw is I like to give it a visual inspection. Visually, I'm looking for nuts, cracks, housings, loosened up bolts, those kind of things, leaking fuels, duct tape, anything out of the ordinary that shouldn't be part of the saw. I always like to tap the muffler before I go to work because they get hot and cold and hot and cold. There's a lot of expand, contract going on, and they loosen up. So I might want to make sure that that's nice and tight. Fuel, you want to use 89 octane fuel or higher. Mix it to the ratio that it is stated as. 50-1 being 50 parts gas, 1 part oil. You don't want to mix it less or more. You want to mix it according to what the manufacturer's instructions tell you to do. There are also good can fuels that are 95 octane that have the mix right in them, and they do not have ethanol, and they are a good source of fuel as well. Bar oil. Bar oil will go into the front of the saw. You want to use bar oil because, first of all, bar oil is delivered to the top saw through this hole here. As it goes from the top, it's carried around the bottom so that you get a lot of lubrication on the bottom of where you're cutting mostly. Motor oil, which a lot of people might use, 80 to 85% of that is strung off the top. It never makes it to the bottom of the bar for lubrication. So bar oil has a tack agent in it that keeps it on the bar. There's also an environmental additive to it that keeps dirt from adhering readily to the oiler mechanism, so we don't create load of the motor when we accelerate up and down. We want it to be free, all the power to go to the cutting. And bar oil has a very high flash point. It doesn't burn readily. So use bar oil specifically designed for chainsaw, if you will. Looks overall, everything's pretty good on the saw. Well, my visual inspection, I do have some chain hanging off the bar. Obviously, that's no good. So we want to tension it to make sure it's tensioned properly. It's on the sprocket, it's turning. This saw actually adjusts from the side here in the back. I'm going to just turn it clockwise to take up the slack out of it. Obviously, the bar nuts need to be loose. And I'm going to turn it so that that slack comes out so it's tight to the bar. Now, if you notice, the bar does have a keeper or a catch point in it, so you should make that adjustment by holding up on the bar or lifting up on the bottom of the handle so that there's pressure to the top, or you could turn the saw upside down and work on it. Irregardless, you want this position of the bar to be all the way to the top. Once it's in the bar rail, you want it to move with a gloved hand. You want it to pull and snap to go in there, and you want nothing hanging off the bar, and you're pretty good to go. You can tighten down the back nut first. You should always do that and give it another check. So we pull, snap, and we have movement, nothing hanging off the bar, and now we can tighten the front bar nut, and we're good to go. You want that snap in there because as the saw cools down, the chain contracts, and we don't want to risk any damage to the bar, sprocket, or the crankshaft or the sprocket at the drive area of the saw. So visually, I think we're good to go. Full of gas, full of bar oil, nothing's cracked on the saw, everything's good to go. I want to make sure that the safety features of the saw are in good working order. The chain brake has to activate, has to deactivate freely. So you have a moving chain. With the brake on, you have a non-moving chain. You also want to make sure that your throttle interlock is intact. Throttle interlock is a device on the rear handle that does not allow activation of the throttle unless your hand is directly on it to activate. It also, by putting your hand on it, pulls the chain, keeps the chain close or in the front area of the operator, if you will. It's part of the ergonomic outset design of the handle. When you put your hand on it, it tends to create a situation where that bar is working in front of you. Chain catcher pin. Chain catcher pin is a device on the bottom that shortens the distance of the chain by half if in turn the chain breaks. It's pulled from the bottom of the clutch, so it's going to wrap around this chain catcher pin before it would get into the operator and so forth. You want to make sure that that is intact because in turn it could break if you have severe enough occurrence, but there should be a device, could be metal, could be polymer, on the bottom of the chain that if the chain breaks, it's going to wrap around that instead of getting into the operator. Stop switch. Obviously, it's the only thing that's red on the saw. It should be activated to stop the saw. You don't want to use the choke to stop the saw. You want to make sure you have a functioning stop switch that is on the saw, and down to stop it. AV system, the anti-vibration system, the springs are intact and we don't have anything that's broken. Good handle adjustment to the frame, so we're good to go in that respect. Spark arrestor screen could be a maintenance item. You can, most saws crack the chain brake forward and it gives you visual access to the spark arrestor screen or a chance to take the little screw out and replace the screen. You shouldn't burn those screens. If you're going to reuse it, you should scrape it with a wire brush. Burning it creates fatigue to the little mesh screen and it can break off and get into the intake and create some problems. So you want to have a working spark arrestor screen on there that prohibits a spark from getting out of the exhaust onto the ground to where it could create a fire hazard. So visually, we're good to go, and our safety features seem to be good and intact. The third thing we want to do is check our air filter. And I don't want to insult anybody, but an air filter, which seems to be the most common maintenance item, oftentimes is the most overlooked. When you pull off the top cover, this is before you take the filter off, it is a really good time to either brush the fins and the flywheel so that we create not a barrier that creates insulation of wood and chips and so forth, so that that heat dissipates. That's the cooling system of the saw, along with the oil mixed with the gas properly, so we're good to go. If you have compressed air, spraying it out works really good. If you have a dirty filter and you need to take it off, set the choke on the saw, because the choke will close the throttle plate or throttle plates. This is a very advanced design, it's got two, but it creates a barrier such that if you drop dirt as you're pulling the filter off the saw into the body, you can lightly blow it out. You have some barrier before it gets into the motor. To check the air filter, I'm just going to hold it up to light, and I can see light passing through it. So we're good to go. This is a flocked air filter, F-L-O-C-K-E-D. It's a paper filter with a coating around it. So most people would tend to brush this. Brushing's okay. You want to do that lightly because you can brush the flocking material off, and in turn you can brush the dirt further into the filter. So blowing it might be an option. Obviously, blowing it would be blow inside out with light air. If you put too much air pressure onto the filter, you can open up the pores and you reduce the micron rating of the filter, and it's not going to filter that light sand that would get into the carburetor, create problems with starting and or performance with issues down the road. The best way I find to clean an air filter, because you get a lot of carbon around it and a lot of other things other than just the dirt, the wood chips or dust, is to take a coffee can, fill it up 3/4 of the way with warm water, put maybe 8 drops of dish soap, just normal detergent dish soap in it, and drop that in and soak it for about a half an hour. Pull it out and rinse it, and let it set on the shelf for 24 hours to dry. So that's the problem, that drying period. So obviously common sense says that another filter around as a backup is good sense, if you will. A chainsaw this size will take in more air in 60 seconds than I will breathe in 10 hours in a day. So you can understand how critical and how important the air filter is, and air getting in so that it can be mixed with the right amount of fuel for proper performance. So we got our visual inspection, our safety features are intact. We've got our air filter clean, and we want to now look at the bar, chain, and the sprocket. So to take the bar off, I'm just going to take the bar nuts to the back. We'll loosen those up. Pull the side cover off. That takes a second. I've also got pressure on the adjuster pin here, so I'm going to just back that off a hair bit, and that should slide off. And then I can take the entire bar and chain off with gloves in one setting. So now I've got the bar and the chain off. First thing I do with my bar is I sight down it to make sure it's flat on the top. Those bar rails tend to V out a lot with the chain running through there. They tend to wear, so you want that surface to be flat. I see a lot of folks trying to flatten those out with a flat file, which creates more harm than good. Really a great tool to have is a 90-degree file guide, which just sits right on the bar at a 90-degree angle then, and allows you to take that top rail down to make it perfectly flat. You can also do the burrs. You get some burrs on the sides of the saw that create an area that's wider than the cut itself. We call that the kerf. So you can take that off as well. So there's really 6 surfaces you can do with your 90-degree rail dresser: the sides, the tops, 6 surfaces totally. Now, at a minimum, I'm good now with a flat file working just on the edge of your tailgate, of using a flat file to take that burr down. That's perfectly fine, but it's really tough to get that top rail to be flat. We want to get the grit out of the inside of the rail, because as the chainsaw is running, it tends to run up higher and higher out of the rail, and it creates a lot more movement of the chain than what we want to work properly. So that can be done with a number of tools. I think a business card works just the best. Fold it over in half and pull from the nose back. I've got a little soft metal device here that's designed for that. It just goes in, and you're going to pull it all the way down, and it pulls out all the dirt and debris that are sitting in that rail that creates that chain riding up higher and higher. After I do that, you want to clean the dirt out of the supply hole, because you've pulled all that dirt back. It plugs that. Invariably, the saw would be pumping oil from the saw to the bar and not even making it to be carried around by the chain, because that hole is filled up. So after I clean the rail out, I just want to go around and clean out the holes on that. The sprockets on the bar should be rounded. They shouldn't be pointy. You want a round nature. You don't want a pointy, sharp like a throwing star. That would tell you that your sprocket is in good shape. And the sprocket at the drive area has actually got, and a rim sprocket has actually got witness marks or lines on it that can tell you when the wear is such that it has changed the pitch of the chain. Now on the bar, it does tell you the pitch, and it tells you the gauge of the chain. It's really important. The gauge on this one is 50 thousandths. And what gauge is think of it very much just like wire gauge. It's the thickness of the tooth that fits down into the chain, or into the bar, excuse me, or it's the inside diameter of the bar rail. Now you can check these if you want, because if you have a dime, a penny, and a nickel around, 3 common gauges are 50 thousandths, 58 thousandths, and 63 thousandths. So I have a 50 thousandths gauge bar. We can see that a dime slits in there and tends to move, but it doesn't slop side to side. So we know we got 50 gauge chain. If we had a penny, which is minted at 58 thousandths, well, a penny, it'll push down in there, but it just does not want to move, if you will. So you couldn't have chain running around with that. So that's the wrong gauge. And a nickel minted at 63 thousandths actually will not fit in there at all. So it's a really good way to check the gauge of your bar in your chain. A dime as well with that coin surface makes a really nice tool for pulling all your grit out of the bar rail. So in a pinch, that can serve a good purpose. That is the gauge of the chain. We want that chain to be sitting in the bar rail, and we don't want it moving side to side. We want it to be in there nice, going around without much flexing side to side. Pitch. The pitch of the chain on this, it says pitch 3/8 inch. Well, the pitch of the chain is the length between 3 rivets divided by 2. If you take center to center of 3 of those rivets, divide it by 2, you get 3/8 of an inch. And what that is a correlation to, it relates to the male drive tangs of the chain and how they fit in relation to the sprocket at the nose of the bar and also at the drive of the bar. So you want it to go in there and you want it to be able to turn. It's got to fit in there and it's got to fit in there tight, and that is your pitch. The pitch also, there's a correlation of the chain, the file size to the pitch of the chain. Now this is a 3/8 pitch chain, and I know that a 7/32 file fits that chain. You can find that out from your dealer or in your owner's manuals or online. Another easy thing to remember is that the right file for your chain is 1/5 or 20% over the top of the tooth. You don't want it to go down below and start hooking that tooth. We'll talk about that in just a second. So you got the pitch of the chain and the gauge. You also have the length of the chain, and this is a 20-inch. Remember that the bar is measured from the front of the housing out. It's not the entire length of the bar. It's actually from where it would be at its furthest position out on the saw. And drive lengths, this is 72 DL drive lengths. We measure the chain by these drive tangs on the bottom because the pitch being longer or shorter will create more or less teeth on the top for cutting, but it's never going to create more or less teeth, or the drive tangs on the bottom, they're always going to be the same for the same pitch of the chain, if you will. Okay, so we got our bar pretty good to go. It always makes good sense to just brush this area out where the bar oil comes out. You can also clean out around the sprocket where the brake band goes on and off. We want to make sure that that is nice and clean, and you can use that little bar groove cleaner to get all that dirt and debris out. We're good to go. Everything is pretty good. Rotate the bar. If the bar was on upside down when you took it off, you want to put it back on right side up and so forth so that we get equal wear to all cutting surfaces. The chain is just going to, the bar is going to go on. The chain is always, remember, points are pointing forward. So there we go, and it's gonna, let's get around here real quick. It's gonna go on the sprocket first. I like to just loop it right down the top, if you will. You can do it various ways, get it on there. I pull the slack out of it. I just wanna make sure that it's turning on that sprocket and on the bar. After I get that, there is a chain pin here that has to align to a hole in the bar. So it's going to just go on, and it does fit or align. You might have to change the tension of that ever so slightly to get that pin to match the holes on the bar. Again, as review, we're going to put the bar nuts on, get them snug but not tight. You know, when you want to be able to move that pin, we're going to raise up on the bar and take that tension out, turning it clockwise. That's really nice having that chain adjuster on the side. It pulls and snaps and has movement, so I'm good to go. I'm going to tighten the back nut. I don't need a 3-foot pry bar on this thing. I want to do it tight. After I do the back nut, try it again. I got movement. Now I can go ahead and tighten up the front nut, and I am good to go. Regarding the chain, the most important part of maintenance, probably aside from the safety features, is the chain. Before I go to work, I take a look at the top down and from the side, and I can tell you that that chain is sharp. And I know chain is a feel thing for most of you. You know when it's sharp or whatever, but we want to make that correction maybe in the shop or before we get out to the back 40, and then we're out there and we got dull chain and we got to go all the way back, or we don't have the tools. We want to make sure we check it before we go to work. What I'm looking at from the top down is essentially the top plate angle. This line here has to mimic the line at the back of the tooth. Now, all of our saws have this line which tell you the angle that you want to keep this file, the chain filed at, and also how far back you can file before you can't file anymore. So that's a great tool, a great guide to have for filing chain. I'm also, from the top down, not only am I looking, is that line parallel to this, but I'm also looking at, do I have a sharp point? The point is the first thing into the wood, and the point will get rounded. It won't be pointy when you're looking down at the top when it is dull. From the side, I'm looking at, this is the depth gauge. Is the depth gauge lower than the top of the point? And yes, it is, because the basic aspect of this, how it works, is as the wood comes in, it hits the depth gauge, bucks it up into the point, and drives it out. So you have a distance here of about 20 thousandths for hardwood and 30 thousandths for softwood. There's enough power to drive it out, but that's where that reactive force comes in turn, because it's not a smooth wheel. You do have a little bit of give to it, if you will. On the bottom, it does the same thing, into the point, and then we talked about that kickback on the top corner. So from the side, is this lower than the top of the point? And I'm also looking at from where the gullet rises. This is the gullet inside here, just where it starts to rise. Is that line visually straight up to the point? That's what you want. You don't want that line going forward, and you don't want it going back. You want it to be 90 degrees. So again, in review, top plate, depth gauge, the point, the side plate at 90 degrees, and if you have the right file, 20% or 1/5 over the top of the tooth creates a radius in this tooth of about 45 degrees, which is the line underneath here. Those are all the 5 parts. Depth gauge controls the depth, the point does the cutting, the top plate is angled down at about 8 degrees, which moves the chain engineering-wise to the outsides, so it creates a cut that is wider than the bar and the chain and the rivets itself. And the depth gauge has to be lowered after it's filed down, because you notice that the tooth slopes to the back. What happens as it comes up into the point, we have to have it sloping back to begin with, so as the depth gauge raises it up, it's now going through my wood flat and straight. It doesn't hit the back of the wood, creating a lot of chatter. If it was straight to begin with and not slope back, the wood would hit the depth gauge up, and you can see it, the wood, as it's trying to clear over the back of it, it's going to hit the back of the tooth. It creates a lot of chatter. So by going downhill, you have to understand that you have to lower the depth gauge at some point in time. So I've got a chainsaw here. I want to show you a couple things. I basically have the right file, 20% or 1/5 over the top. I'm going to hold the file down at about an 8 to 10 degree slope, just a little bit of a slope. Remember, that's how that tooth moves to open up the kerf. And I want to file at the right angle. Now, the file handles that I use have the angles built right into the file handle. That's pretty smart stuff, if you ask me. There's your 30 degree one, and here's a 25 degree one for the saws that I'm using. And such that when you come up with the file and put it straight to the bar, it's going to put that file in the proper angle for the tooth that you're filing or what you're working with. So that makes a lot of sense. So the right file, angled and down, stroking forward and releasing back. You don't want to stroke up and pull back, because it changes your angle, because it bites, the point of the tooth bites onto the file, and it also ruins your file, because files are directional. They're made to go one direction only. So when you go up and back, it's clearing the file shavings out, but it's not ruining the file. You're going to do that as many times until you get a straight line to the point. One of the problems is hand filing is pushing down instead of pushing towards the motor. You don't want to go down, we want to go back this way. And there are a number of tools that are available that help you with that action. This is a file guide, and the file guide is designed, it's a bar around a round file. When it goes on the bar, all you have to do is stroke it, because you cannot push down into the tooth, because these bars stay up on top. Makes a lot of sense. It also has lines on it that tell you the right angle for filing, so it really helps you keeping that top plate angle at the right angle for your particular situation. This is a tool that I love to use. It's just called a combination gauge, and all it does is it sits down on the chain, and it doesn't allow the file to go too deep into the tooth, and it keeps the file kind of running at the right angle. It's called a combination gauge because after you have filed this tooth, you have to lower the depth gauge. It has the depth gauge settings built right into the file guide. There's a hard setting and a soft setting. If you're cutting hardwood, the distance between the depth gauge and the top of the point is lesser than for softwood. If you're cutting softwood, you can actually lower this down. In other words, you can increase the amount of bite that you're taking out, or the chip size of the tooth, without slowing the saw down. But if you have good hardwood, we want lesser chip and we want to make more of them. It doesn't make any sense taking this down and taking out one big chip and having the saw run it at maybe 6,000 RPM. Too slow, very dangerous for you, very hard on the equipment long term, takes away a lot of life, if you will. So you want to lower that down for the work that you're doing, and this would have on this combination tool hard setting and a soft setting, and all it does is sits over the top of the tooth. What is too tall exposes through the little hole, and you're going to just take that off. So a really nice guide. You have to know the pitch, 3/8 pitch. It tells you the pitch on the bottom side of the file. You also know that you've got the right file for the guide, because that is all set up to go together. I mean, I can go out into the woods with these 3 tools here, and I can do all the filing, maintain that, everything I need to do in a day's time. My favorite tool is this Sharp Force sharpener. If you look at it, it's got everything combined in one that I just talked about. It's got the bars here. Put it this way so you can see it. So it keeps the file up high on the tooth. It doesn't allow it to sink down too far into the tooth. It also has a flat file in front of the round file, so that as you're filing this, it's going to lower the depth gauge relative to how much of the tooth you're filing. It does it all in one tool. So this makes a lot of sense to me. Bar, chain, and sprocket. Your chain is the most important aspect of this for cutting, productivity, and safety. Your saw should be cutting 1 inch per second through hardwood. If it's not, you got some situation there that's probably related to the maintenance of the saw.